Yes. Hello students. In today's session of NCERT chapter, Dual Nature of Matter and Radiation, class 12 physics. Very basics will be cleared through illustrations on the topic of photoelectric effect. In earlier session, we have gone through this, which you can review on YouTube channel sethiswiftlearn. In today's session, we are going to discuss what are laws of photoelectric emission, discussion regarding Einstein Photoelectric Equation, nature of graphs, tell the principle of straight line, and illustration also. Going to be very important for 12th standard, CBSE board, NEET, JEE, and other entrance examination. It is requested go through the session completely. Now let's start with the question. Question is, state laws of photoelectric emission. In totality, there are four laws. First is, for a given material and a given frequency, means for material is fixed and frequency is fixed. Of incident radiation, the photoelectric current, or another way we can say number of photoelectrons ejected per second is directly proportional to the intensity of incident light. What is intensity? Intensity, number of photons per unit time per unit area, provided frequency is fixed, material is same. In that case, current is proportional to the intensity, right? Second law is, for a given material and frequency, again be careful, material is same, frequency is fixed. Saturation current, that is the maximum current, is found to be proportional to the intensity of incident radiation, whereas the stopping potential is independent of its intensity, right? Third one, for a given material, there exists a certain minimum frequency of the incident radiation below which no emission of photoelectrons take place. This frequency is called threshold frequency. F should be greater than F naught. This is the essential condition. Above the threshold frequency, the maximum kinetic energy of the emitted photoelectrons or equivalent stopping potential is independent of the intensity of incident light, but depends only upon the frequency of the incident light. And fourth one is, photoelectric emission is an instantaneous process. The time lag between the incidence of radiation and emission of photoelectrons is very small, that is less than 10 to the power minus 9 seconds. So four laws, I will brief it here again. One is instantaneous. F should be greater than F naught. I is proportional to intensity. Kinetic energy maximum or stopping potential is proportional to frequency, not on intensity. In brief, we can pronounce it like this. Right? These are the four laws. Right? Next question. Question is, state Einstein Photoelectric Equation and discuss terms involved. Einstein Photoelectric Equation is E equal to phi naught plus kinetic energy maximum, or you can say phi naught plus EV naught, where phi naught is a work function, E is the energy incident on metal surface, maximum kinetic energy, that is half mv maximum square. V naught is stopping potential. Stopping potential E is the electronic charge. Electronic charge. This is the Einstein Photoelectric Equation, right? What is work function denoted by phi naught or W naught? It is a minimum amount of energy is required to pull out a free electron from the metal surface of the metal. From the surface of the metal. This minimum energy required by an electron to escape from the metal surface is called work function of the metal. What is work function? This is the minimum amount of energy required to pull out a free electron from the surface of the metal. This minimum energy required by an electron to escape from metal is called the work function of the metal. Generally, it is measured in electron volt. It depends on the properties of metal and nature of its surface. It decreases with increase in temperature. 1 volt of 1 electron. What is 1 electron volt? Is the energy gained by an electron when it has been accelerated by a potential difference of 1 volt. So 1 eV equal to 1.6022 minus 19 joule. This is the unit of energy. This is the energy. The work function of platinum is the highest. Metal is platinum. That is the highest. That is 5.6 eV. While it is the lowest for cesium. That is 2.14 eV. Right. Next, stopping potential. For a particular frequency, again repeating for a particular, if it is fixed, and metal is fixed, frequency incident radiation when minimum negative potential V naught is applied to the anode with respect to cathode, at which photoelectric current becomes zero at the particular value negative potential V naught, called stopping potential or cutoff potential. Means negative potential applied when emission of photoelectrons ceases. That is the stopping potential. Right? Next question. Before start of the next question, I would like to say that these concept clearing videos for the purpose of 11th standard, 12th standard, state boards, CBSE board, JEE Main, JEE Advanced, NEET, CUET, and other entrance examination. These concept clearing videos are very helpful and useful, which you can review on YouTube channel sethiswiftlearn. In addition to this, I would like to say that these papers, complete video of sessions are available on sethiswiftlearn YouTube channel, which you can review on sethiswiftlearn. In addition to this, further, these papers, detailed solution with additional information available on website sethiswiftlearn.com. You can visit the site and have the solution. इसी के साथ साथ मैं रिक्वेस्ट करना चाहूँगा कि अगर अभी तक आपने YouTube चैनल sethiswiftlearn सब्सक्राइब नहीं किया, प्लीज सब्सक्राइब इट एंड शेयर विद योर colleagues and friends. Now let's start with the question. Question is, maximum kinetic energy of photoelectrons from metal surface is K0 when wavelength of the incident light is lambda. If the wavelength is decreased to lambda by 2, the maximum kinetic energy of the photoelectron becomes, 3 options are given to you. One of the option is correct. Right? Concept applicable solution. Einstein Photoelectric Equation. What is that? Energy of incident radiation equal to phi naught plus kinetic energy maximum, right? This kinetic energy maximum generally I am discussing another is equal to half mv maximum square, and that is equal to ev naught. Depending on the requirement, which term is to be used, right? This can be written, E can be written as h mu, that is equal to sc by lambda equal to phi naught plus kinetic energy maximum. That is sc by lambda equal to phi naught plus kinetic energy maximum. This is equation A. We will use this equation according to question. At lambda kinetic energy maximum is equal to K naught. At lambda by 2, to find out kinetic energy maximum, that is say K. Now from equation 1, sc by lambda equal to phi naught plus K naught. Then sc by lambda by 2 equal to phi naught plus K. Right? On division, we will get sc by lambda, ये 2 आ जाए तो 1 by 2 equal to sc by lambda equal to phi naught plus K naught phi naught plus K. K equal to twice phi naught plus K, twice phi naught plus twice K naught. So K comes out to be twice K naught plus phi naught. Right? So which is greater than twice K naught, which is greater than twice K naught. Let's see the answer. Answer is B. B option is correct option. B option is correct option. Right? Next question. Question is discussed regarding the following graph. Frequency stopping potential graph, frequency and maximum cardiac energy graph. First of all, we will discuss the frequency stopping potential graph. Before we discuss the graph, let us discuss certain concepts. Straight line y equal to mx plus c, known as slope intercept form. Slope intercept form. Graphically, it is represented as this is theta, this is c, y-intercept. M is slope, that is tan theta. Theta is angle made by the line with positive direction of x-axis, anti-clockwise, yani like this. This is theta. And C is y-intercept. In this case, we replace quantity on x-axis, by x, and on y-axis by y, and make the comparison. Right? Now, in this equation, we have to draw the graph between two. E equal to phi naught plus stopping potential EV naught. Y-axis पे तो EV naught taken on the side, and frequency. Frequency में क्या आएगा? E equal to h mu minus phi naught. V naught comes out to be h by E V naught plus minus phi naught by E. Comparing with y equal to mx plus c. Slope is, this is the slope, multiplier of x is slope h by e. This is the slope, this is the y-intercept. This is the y-intercept is minus phi naught by e. The slope is h by e. Right? Now the discussion of graph between frequency and maximum kinetic energy. In this case, we have to pick up the term. This is on x-axis, this is on y-axis. Right? So E equal to phi naught plus kinetic energy maximum or phi naught plus EV maximum, EV naught, or phi naught plus half mv maximum square. E can be written as h mu or sc by lambda. जो पिकअप चाहिए, जो चाहिए उसको पिकअप कर दीजिए. We want y-axis kinetic energy maximum. Means this is our y and frequency. Means we want h mu equal to phi naught plus k. That is, kinetic energy will be equal to h mu minus phi naught. Comparing with the standard equation, that comes out to be h mu plus phi naught with negative sign. Okay, this is your y, this is your x, this is your m, this is your c. Right? So y-intercept is a work function. Slope is Planck constant. Slope is Planck constant. The graph is a straight line passing like this. Right? Now, I would like to request, if you are new to my YouTube channel, sethiswiftlearn, sethiswiftlearn, please like and subscribe to my channel and press bell icon to receive updates on concept killing videos. Thank you. धन्यवाद, बहुत बहुत धन्यवाद जी, बहुत बहुत धन्यवाद.